All right, welcome to The Explainer. If you're studying to be a game developer, or maybe you're just starting out in your career, think of this as your guide. We are going to dive into what it actually takes to build a video game, from that first spark of an idea all the way to a polished final product.
So let's just jump right into it with this quote. You know, it's so easy to think that game development is all about mastering code, right? Learning the most complex engines. But, as Stuart Yarn points out, the tech is more accessible than it's ever been. The real battles you're going to face, they're often about managing creativity, trying to wrangle a super complex process, and just getting a whole team of people to move in the same direction.
Every great journey needs a map, and in game development, that map, it isn't code. It's a document. It's called the Game Design Document, or GDD, and it's where your entire world first truly takes shape.
Okay, so this GDD is basically your project's North Star. It's a living, breathing document that outlines every single key element, from the core gameplay and the art style to who you're even making the game for and how it might make money. But its most important job? Making sure the entire team, from the artists building the world to the publishers funding the whole thing, shares the exact same vision for the game you're building.
So here's the crucial part. Once you have that brilliant vision down on paper, how in the world do you manage the intensely complex and, let's be honest, often chaotic process of actually building the thing?
A lot of studios, both big and small, turn to what are called agile methodologies, and one of the most popular is Scrum. See, instead of trying to plan out a multi-year project from day one, which is basically impossible, Scrum breaks that giant mountain of a task into small, manageable chunks called sprints. This whole process lets the team build, test, get feedback, and adapt on the fly, which is absolutely essential in a creative field where, the fun factor isn't something you can just plan for in a spreadsheet.
But look, there's no single silver bullet for managing a project. Let's take a look at how two of the biggest names in the business handle it. Epic Games, they use this super complex branching structure. It's almost like a roller coaster. They do tons of QA testing on each little branch before any of that code ever touches the main game. It's all about stability. Meanwhile, a studio like CD PROJEKT RED prefers a single source of truth, one stable mainline where they can watch all the changes and even automate testing. So two totally different philosophies, both aiming for the same thing, a stable game.
Okay, let's get into the part of the journey that every developer faces, but not enough people talk about, especially when you're just starting out. We're talking about the hidden costs, the things that can completely derail a project, and maybe even your passion for it.
As a developer, you are inevitably going to run into two major challenges. Two beasts, really, that can mess with your game, and more importantly, your own well-being. Knowing what they are now will help you spot them later, and they are technical debt and crunch culture.
Okay, beast number one, technical debt. The best way to think about this is like taking out a loan. You take a shortcut right now to meet a deadline, but you're creating a problem that you or some other poor developer down the line will absolutely have to pay back later with interest. And that interest comes in the form of bugs, slow performance, and really frustrating rewrites. Now this is where it gets really interesting. Look at how a studio like Riot Games thinks about this debt. They don't just ask, how hard is it to fix? They measure its impact on players and on their own developers. And most critically, they measure its contagion. In other words, how fast is this bad code infecting other parts of the game? A small contained problem is one thing. A problem that spreads like a virus, that is a 5-alarm fire.
And this perfectly illustrates one type of debt Riot talks about, MacGyver debt. Yeah, named after the 80s TV show. This is what happens when you just force two systems together that were never ever designed to connect. The Seattle City grid is a perfect real-world example. You have these two different grids just mashed together, creating all these awkward, inefficient intersections. In your code, that duct tape approach creates bugs and friction at every single point where those systems touch.
And then there's the even scarier data debt. This is when you have tons and tons of content, art, character scripts, level data, all built on top of faulty code. The code underneath is the problem, but fixing it is a super high-risk operation. It's kind of like trying to edit a single gene in a strand of DNA. You have no idea what other critical functions you might accidentally break in the process.
The second beast isn't about code, it's about people. Crunch culture is the industry's term for these long periods of intense overtime, which for a long time has been sort of normalized as just part of the job to hit a deadline.
As you get into the industry, you've got to know that this isn't just about people being passionate. Research shows that crunch is usually a symptom of bigger, systemic issues. Bad project management, something called feature creep, where new ideas just keep getting added without adjusting the timeline, and sometimes unregulated labor practices. And the effects are serious. They lead to developer burnout and can have some pretty significant health consequences.
So, how do you conquer these beasts of debt and burnout? Well, it takes discipline, especially as you get your game across the finish line. This is where you take a project from something that just works to something that is stable, fast, and genuinely fun. It all comes down to the final polish, rigorous testing and optimization.
Okay, first, it is absolutely crucial to understand that there are two very different kinds of testing. Quality assurance, or QA, is all about technical performance. Is the game stable? Does it crash? Are there weird graphical glitches? Playtesting is completely different. Its only goal is to answer one question: is this game fun? You can have a perfectly stable, bug-free game that is incredibly boring. You need both. Both are essential.
Now here's a powerful practice from the wider world of software engineering that's being adopted more and more in games: test-driven development, or TDD. This kind of flips the script. Instead of writing your code and then testing it, you write the test first. It forces you to think about exactly what the code is supposed to do before you even write it, and it builds this safety net that can dramatically cut down on technical debt by making quality a core part of the process, not just some afterthought.
And on a practical, nitty-gritty code level, optimization is not optional. Think about low-poly models. Instead of forcing the game engine to render an incredibly complex object, you use a simpler shape and let clever textures create the illusion of detail. The same smart thinking goes for something called object pooling. Rather than constantly creating and destroying a bullet every time you fire a gun, which just eats up memory and CPU cycles, you create a pool of them at the start and just activate and deactivate them when you need them. It's way more efficient and it's essential for a smooth experience.
At the end of the day, building a great game is a balancing act. It's a balance between wild, creative ambition and disciplined, sustainable execution. So the central question that you all will have to answer in your careers is the one right here on this slide. How do we build these ambitious, groundbreaking games without racking up crippling technical debt and, way more importantly, without burning out the talented people who bring these amazing worlds to life? That's the challenge for your generation.